No problem, huh? Okay, perfect.
Slide before this, you saw the C1, DC power supply. So I would like to ask teacher, is it necessary to use all the things that are stated here, but I do not want to use it? Can it be like that?
One more time.
Like in my list of apparatus and materials, I do not use DC power supply, but it says here, use apparatus such as DC power supply. Can I do that?
Okay, if the question said use DC power supply, you need to follow that. Okay, you need to use DC power supply.
What if I don't?
You want to replace it with what? So what will be the power supply that you use? Battery is a DC power. Battery will be just like DC power supply lah. Okay, then I think it's better just use what is given in the question, because battery is also a type of DC supply. Alright, dry cell kan? So just use DC power supply lah to make it easy. Because why? If you replace it with other apparatus, the other apparatus that you replace might be not correct. Okay, so safe to use the one that is given. Alright. I think, do you have it in your slide?
No, actually, I couldn't find it.
Oh, you want to draw? Can, okay, but just let on the screen the procedure just now. Okay, class, comment class. Any comment on the procedure? Yeah, any comment on the procedure? Anybody? Ada salah kah? Or is it perfect? Leno, perfect je. Is it perfect, Las? Electric circuit arranged as shown in the diagram. 100 cm long constantan wire with SWG 24 connected across terminal X and Y. The length of wire is adjusted until L 20 cm. Switch is closed, rheostat adjusted to fix the emitter reading to the current 0.5 ampere. So the reading of the voltmeter for potential difference recorded. And then you repeat the step to another 1, 2, 3, 4 more length. Then calculate the resistance by using the formula, and then graph of resistance length plotted. I can say this is a perfect procedure. Okay, perfect procedure, because you have your first mark manipulated variable. The first length is 20 cm. Then after that, the second one is the second mark class is step number 6. Can see or not? Step number 6. This one. If you don't have this, there will be no second mark, because your hypothesis just now is about resistance and length. So you must have the formula to calculate the resistance. Is it clear or not? Jelas class? Okay. And then plot your graph.
So this is how the diagram looks like. You guys can see it or can understand why this is important because we did it before. So this is how the arrangement is supposed to look like.
Okay, good. Anything that you need to label in your diagram following your procedure? Look at your procedure. Maybe look at step number 2. Something need to be labeled in your diagram. Okay, good. Class, ada problem class? Is it clear or not? So look at the diagram. Look at the diagram. So here the ammeter must be in series. Voltmeter must be in parallel. And then make sure you label this wire. Mesti label lah. The wire must be labeled. And then make sure your terminal of battery is correct. Okay, jangan panjang pendek panjang pendek panjang. Faham ah? So mesti tepat lah. Okay. And then do you have switch on the switch in your procedure or not? Adakah? Ada or not? The switch must be on. Correct. Yes, good. Okay. Next. Nice slide, no, Britnesa? Okay.
This is the current, voltage, and the resistance. Because we need to measure the resistance, this is the formula that we have to use. Like this.
Okay. Class, any comment on the title of the table? Title for each column? Anything that you want to add in? Perlu tambah apa-apa class? Jeremy? Need to add what? There are 3 things that I always emphasize on. Apa class? Yes, Erna? The name of the quantity. Class, like this is also okay. Provided in your procedure you already highlight the symbol that you use. But for me, class, it will be better if you add in the name of the physical quantity. What I mean is, just like the first column, length here, length, class, better to write length, L stroke cm. Current will be current, I stroke ampere. Here is voltage, V stroke V. And then here, resistance, R stroke ohm. The name of the physical quantity. It means that you need to write in front here, comma. Okay, current, I stroke ampere. That will be better lah. But for this, for your answer, in the procedure just now, it is very clear what is represented by L, I, V, and R. Okay, but better to have extra that in your table. Okay, huh? Okay, good.
And then this is some data. It is like, what do you call this? Directly proportional, yes. Y-axis is directly proportional to x, but what is y-axis and what is x? From here we can see, look back at the end. Length of the wire and the resistance. Hence, the length of the wire is x-axis and the resistance is y-axis.
Okay, resistance, R stroke ohm. You see, you have 3 things, name, symbol, unit, capital R. The graph inside, you don't have to draw because this is just planning experiment. But if it is a theory question, class, is the relationship like that? The longer the length, the bigger the resistance ke ataupun the other way round? Is it the other way round? The longer the length, the bigger resistance, or the longer the length, the smaller the resistance? Think first. The longer the length, the bigger the resistance. So it is like this. Okay? Faham? Alright. Okay. Okay, do you have similar question to this? Okay, it's okay. So any more after your slide? After this slide? Okay, perfect lah. Britnesa, I can see your effort. Very good. Okay, very good.